Hello dear students, welcome to pre-stressed concrete structure class. In your lower semester, you have studied the concrete technology, analysis of structures, design of concrete structure and design of steel structures. In this semester, you are going to study the subject of pre-stressed concrete structure. We know that what is stress? So the definition for stress is nothing but the resistance offered by the material against external force. Next, what is pre-stressing? What is pre-stressing? So pre-stressing nothing but it is a compressive force. It is a compressive force to be applied in the structures at the initial stage. A pre-compression to be applied in a structure at the initial stage to counteract the stress which to be developed during the service stage by the external force. So look, listen my words. So pre-stressing force is a pre-compression which can be applied in a structure to counteract the stress which were developed by the external force during service stage. Now I think we can look some pictures, then you can understand easily. So the pre-stressing is the application of an initial load on a structure to enable it to counteract the stresses arising from subsequent loads during its service period. So this is some examples for pre-stressing. A force fitting up metal bands on wooden barrels. See here, this is a wooden barrels over which a metal band is provided. Metal band is provided, which offers a compression to these wooden barrels. Okay, so these metal bands create a compression around the barrel. So when this barrel is filled with liquid, the liquid will tries in the outward direction, will try to push out it. So that time this barrel subjected to tension. So again, look clearly. So when it is subjected to water, when it carries the water, this barrel carries the water, that time this barrel will bend in the outward direction. The water will push the liquid will push in the outward direction. That time these metal bands will offer a compression and will control the bending in the outward direction. Okay, so hoop compression created by the metal band counteracts the hoop tension that is created by the liquid while filling the barrel. Okay, so the same concept is used in pre-stressing concrete structures. Now you can clearly understand the concept of wooden barrel. See, this is a wooden barrel. All the wooden barrels are connected by metal bands. When it carries the liquid or any other solid things, usually that barrel can be used for storage of grains and liquids. Okay, so that time that grains or liquids to push the metal band, sorry, it will push the wooden stays in the outward direction, but these metal bands will not allow the outward movement of the wooden barrel. See here, this is the your wooden stave. Wooden stave, it is considered as a free body. It is subjected to compressive force on either side by the by the metal bands. Next, some examples for free stressing. So when we are going to library, we are not easily take the book when it is books are placed very closely, because a compression is offered by adjacent textbooks. Okay, similarly, look here. So so when I am applying a force on either side of the books, no one can take the no one can take the book easily, because it is subject to a pre-compression. Okay, so this is the same the same concept was used in pre-stressing technique. Some examples of pre-stressing. So concrete, in which the effective internal stresses are induced before the structure is loaded to counteract the stresses resulting from the applied service load. After pre-stressing, when the structure is subject to external loads, the stresses due to pre-stressing counteracts these stresses due to external loads. So now you can get a clear idea in this picture. See, this is unloaded structures. Okay, when it is subjected to loading condition, if it is simply supported beam, there will be a crack at the bottom of the beam. Okay, so this beam gets a crack at the bottom portion when it carries the loads. Okay, so this concept is in reinforced concrete structures. If the same cross sectional area is pre-stressed, when it is pre-stressed during the unloaded condition, it will bend in the upward direction. Look here, this profile is bend in the upward direction, but in this case it is in the normal position. When this pre-stressed member is loaded, okay, it won't get deflect as like in the reinforced section. See here, for the same load, it will reach the normal position only. So this is the advantage of pre-stressed concrete structures. So in order to form a crack as produced in the reinforced section, it required more load. So the more load is required to develop a crack in pre-stressed concrete structure. So this picture clearly gives a exact explanation. A simply supported beam is subject to bend when the heavy load is acting over the structures. The same beam gets cracked. Okay, same beam is cracked. Next, when the same beam is strengthened by steel rods, it can avoid the cracks. But when the same beam, the same rod is subject to pre-tensioning, after stretching of this rod and then releasing it will squeeze out the concrete, which makes a strong concrete. It means that the stretching the rod and releasing the rod, which skews the concrete and makes the concrete more strong. So the same concept, the same procedure is adopted in pre-stressed concrete structures. So by clicking this link, you can see some animation. Okay, you can try. So this is the advantage of pre-stressing. So you can see the long span is possible by using pre-stressing concrete technique. So now we can see the development of pre-stressing concept. So in 1824, ASPE team developed a pattern for Portland cement. In 57, Monir produced steel wires in concrete. In 1886, Jackson introduced the concept of tightening the steel tie rods in artificial stone and concrete arches. In 1926, the Freycinet produced high tensile steel wires with ultimate strength as high as 1725 megapascal. In 1939, he developed a conical wedge for end anchorage for post tensioning. You can see the Freycinet, you can see the anchorage device. This is the anchorage device developed by Freycinet and conical wedge. And this is a conical wedge. So these two people are the father of prestressed concrete. Okay, I mean mainly the Freycinet. Freycinet is the father of prestressed concrete. In 1938, Hoyer developed a long line pre-tensioning method. Okay, this topic to be discussed in the subsequent classes. In 1940, Magnell developed an anchoring system using flat wedges. Okay, so in 1952 there was a federation for pre-stressing, and 1954 there was an institute for pre-stressed concrete structures. Okay, now next we will discuss about the type of pre-stressing. So there are five types. One is external and internal pre-stressing. If a pre-stressing is done within the concrete structure, it is known as internal pre-stressing. If the same, if pre-stressing elements are provided on the outside of the structure, then it is called as external pre-stressing. Okay, and pre-tensioning. If the tendons or cables are tensioned before hardening of concrete, it is known as pre-tensioning. If tendons are tensioned after hardening of concrete, after maturing of concrete, it is known as post-tensioning. If pre-stressing, the axis of the pre-stress is parallel to the axis of the member, then it is known as linear pre-stressing. For example, beam. Okay, if if pre-stressing in pre-stress is adopted in circular beam, then it is known as circular pre-stressing. Okay, next one, full, limited or partial pre-stressing. As per Indian codal provisions, it can be adapted. We will discuss in the next slides. And uniaxial, biaxial or multi-axial pre-stressing. If pre-stressing is adapted in only one direction, it is called as uniaxial for beam. For biaxial, if pre-stressing is adapted in both direction, it is known as biaxial pre-stressing. The best example is pre-stressing adapted in slabs. Multi-axial pre-stressing is the axis of the cable is in multi-direction. The best example is adaptation of pre-stressing technique in construction of domes or at the bottom slab of circular water tank. So these are the examples for multi-axial. So this is a source of pre-stressing force. Hydraulic pre-stressing force is simplest pre-stressing force which produces a large pre-stressing forces. Generally, the hydraulic jacks used to indicate the magnitude of force. In mechanical pre-stressing force, uh, the transmission, lever transmission and gear transmission in conjunction with the pulley blocks, screw jacks, gear drives and wire windings machines, which is adapted for mass scale production. Mechanical pre-stressing is adapted for mass scale production.